Welcome class to this video on graphing quadratic equations and second differences. In this video we are going to go over how to create a table of values based on a quadratic equation, and then from that table of values we will be graphing the quadratic equation, allowing you to see the parabola shape that is created. Afterwards we will discuss some of the key characteristics of the parabola. So to start us off, we're looking at this equation here, y equals x squared minus 1. And we want to complete this table of values by first completing the y column of the table of values. And the way we can complete the y column is by substituting the values that we are given in the x column into the equation here. So I'm going to do that over here on the side. The first value that we've been given in the x column is negative 4. So I would write y is equal to x squared minus 1. I could then substitute in for x, negative 4. I now square negative 4 and I get 16. I now subtract 1 and I now get 15. So the first value that I can put here in my table of values is 15. Just to see that procedure again, y equals x squared minus 1. I substitute in for x squared, negative 3. For x, negative 3. I then square negative 3 and I get 9. And I end up with 8. Okay, so I want you to just hit pause now on the video and complete the rest of the y column. So if you've done your calculations correctly, your y column should look like my y column here. The values you should have there are 15, 8, 3, 0, negative 1, 0, 3, 8, and 15. If for some reason you didn't get the correct numbers, you can look over here and you can see the calculations that were done to obtain the correct y values. Now that we have the correct y values in our table of values, we're going to determine the first differences. And you should remember first differences from last year when you studied linear relations. When you studied linear relations, you learned that for a linear equation, the first differences are the same. Well, that's not going to be the case this time with quadratics, but there is a pattern to it nonetheless. In order to find differences, when we say the word difference, it means typically subtraction. So in order to find the differences, we're going to subtract one row from the other. So here it's 15 minus 8. And what does 15 minus 8 give us? It gives us 7. And then we're going to do the next row. 8 minus 3. 8 minus 3. 8 minus 3 gives us 5. 3 minus 0, that gives us 3. 0 minus negative 1, I know this might seem a little counterintuitive, but 0 minus negative 1 actually means 0 plus 1, and so our difference here is 1. Now we can do the next one. Negative 1 minus 0. That gives us negative 1. 0 minus 3 gives us negative 3. 3 minus 8 gives us negative 5. And 8 minus 15 gives us negative 7. So now we've done the first differences. And are they the same like for linear equations? The answer is obviously no. But can you see the pattern? There's a bit of a hint here by giving you this fourth column over here on second differences. Let's find the second differences. Let's find the differences in the first differences. And if we do that, we do 7 minus 5, and what do we end up getting? 2. 5 minus 3, 2. 3 minus 1, 2. 1 minus negative 1, and again that's one of those that's a little counterintuitive. 1 minus negative 1, and you get 1 plus 1 because subtracting a negative is adding. you still get 2. 2, negative 1, subtract negative 3, again you get 2. If you need to see that one as well, negative 1 subtract negative 3, which ends up being negative 1 plus 3, which ends up giving you 2 again. Right, so you should be seeing the pattern. Negative 3 minus negative 5, and you get 2. So what do you notice? For a quadratic equation, the second differences are always all the same. Okay, and you'll see the first, and when we say the second differences, what is that? That's the differences in the first differences. Now that we've completed the table of values, we can now graph using the coordinates that we get from the table of values. So if you look here, and if you look here, each one of these is a set of coordinates, negative 4 and 15, negative 3 and 8, negative 2 and 3, negative 1 and 0, 0 and negative 1, 1 and 0, 2 and 3, 3 and 8, 4 and 15. So those are all the coordinates that we are now going to graph on this graph. And when we do so, we're going to create a shape known as a parabola. And so you could hit pause and make sure that you've created the scale to match the scale that I've used here. So along the x-axis, I made the scale 1. So each space is worth 1. And along the y-axis, I made the scale equal to 2. The interval is 2. Each space is worth 2. Okay, so make sure you have a graph that looks like that. And now we can begin plotting our points. So negative 4 and 15 is, let's use the color blue, I guess. And negative 4 and 15 is right here. And then negative 3 and 8. And negative 2 and 3. And negative 1 and 0. And 0 and negative 1. 1 and 0. 2 and 3. 3 and 8. 4 and 15. Okay, so now I have plotted all my points. The next thing for me to do is to create a nice, smooth, rounded line. There should be a round at the bottom, in this case, of the parabola. And so I'm going to do my best here. Oh, a little glitch. There you go. Okay, so now I have graphed a parabola. Now that we've graphed the parabola, which is the shape defined by a quadratic equation, it's the shape you see on the graph in front of you, we can now discuss a few of its characteristics. And the first characteristic we'll discuss is that every parabola will have a vertex. And the vertex of a parabola is the peak of the curve. And it's either going to be the low or high point of the curve. That is the minimum or maximum point of the curve. And so in every time you draw a parabola, you can define the vertex. So in this case, if I look closely at our parabola, I can see that the peak of the parabola is right there. That point is 0, negative 1. And so I'm going to complete fill in this section right here so that it says 0, -1. That is the vertex of our parabola. Now we can consider if the parabola is facing up or down. And so what we would say here is the parabola is pointing down, but it opens upward. And so we are going to circle upward here. It opens up. Okay? You can see it's opening up here. Pointing down and opening up. And when that is the case, when it is facing upward and pointing down, then when we discuss the vertex, we discuss it and we understand that we have a minimum. It has a minimum point. It points down. Its peak is the minimum y value for the parabola. In this case, -1. Now we can look at the y-intercept, and you should know y-intercept for when you learned about linear equations. And the y-intercept is the point where a line or curve crosses the y-axis of a graph. So where does that happen in this graph? It happens at the exact same place as the vertex, because the vertex is on the y-intercept, or on the y-axis. And so we would also put here 0, -1. Now that's not always going to be the case. You can have quadratics, for example, that are like this and are crossing at 20. So the y-intercept would be different. Now we can look at zeros, and it says here the zeros of a quadratic equation are the points where the graph of the quadratic equation crosses the x-axis. So where does it cross the x-axis? You can look closely here. It crosses at this point, and it crosses at this point. So going from left to right, this first 0 is -1, 0. And so we're going to substitute here -1, 0. Or write in -1, 0. And then over here, it's 1, 0. Okay, and those are the zeros of the quadratic. Okay, it's the points where the graph of the quadratic equation crosses the x-axis. And I'll show you something that you should recognize about them momentarily. What's our step pattern? So you should know step pattern from the previous video. When we do the step pattern, we're going to draw, and we have a step here, right? How much did the y value change from here? It changed 1. Let's draw another step here. How much did the y value change this time? Went from 0 to 3, so that changed by 3. How much did it change this time from 3 to 5? It changed by 5. So you can see the step pattern is 1, 3, 5. So we can fill that in. 1, 3, and 5. And the last part here, it says, what do you notice about the second differences? As we discussed, the second differences are all the same. So you can just write in here, all the same. Now, before we finish up with this handout, just want to point something out. If you recall from before when we did differences of squares, we had equations that look like this. If you can recognize, this is a difference of square. We did this in the previous unit, and we learned that we could factor it by creating the brackets, square rooting x squared, and we got x. We square root +1, and we get 1, and then we know these signs are going to be opposite. Right, so now you should see this equation, y equals x plus 1 times x minus 1. That is the factored form of x squared minus 1. And now that's useful because if I just had this equation, I could factor it and then use this factored form in order to find these zeros. How would I find those zeros? Well, what is the value of y at those points? The value of y at those points is 0. So I'm going to substitute in here 0 equals x plus 1 bracket x minus 1. I now have two terms. This is one term, this is the second term, that when multiplied are going to give me 0. Now, what that means is that one of them must be equal to 0, because in order to multiply two terms and get 0, one term must be 0. So I can take turns deciding on which ones I want to be 0. So for example, I have here 0 is equal to x plus 1. If I did basic algebra to find the value of x, I would have to subtract 1 from each side. And I'll do it the long way first just so you can see it. I'm doing 0 minus 1, is equal to x. And then I get negative 1 is equal to x. X is equal to negative 1. This is one of my x-intercepts, and you can see it right here. Let's do the other one. 0 is equal to x minus 1. I add 1 to both sides. 1 is equal to x, or x is equal to 1. Here, that is my other x-intercept. Okay, so you can see the usefulness of being able to factor a difference of square, because doing so allows us to see the x-intercepts. Let's now repeat this process with a slightly different equation. We're going to complete the table of values, create the parabola, discuss its characteristics, and then we'll draw some conclusions about the differences in the two equations that we looked at. Alright, so again, to do this we need to complete the y column, and in order to complete the y column we need to substitute the given values of x. So the values of x that were given here, we're going to substitute into the equation here, and we're going to find the corresponding y values. So I'm going to do that over here on the right. Y equals negative x squared plus 1. I substitute in for x, negative 4 squared plus 1. And so you should notice that I put the negative 4 in brackets. The negative that was next to the x squares has to stay to the left. I'm going to do the exponent first. Negative 4 squared gives me 16 plus 1. Now I have negative 1. This is like a negative 1 sitting here. Negative 1 times 16 gives me negative 16 plus 1, and I get negative 15. So I can now put in here negative 15 for y. Do one more example. Y equals to negative x squared plus 1. We substitute in for x, negative 3. We square negative 3 and we get 9. We multiply negative 1 by 9 and we get negative 9. We add negative 9 plus 1 and we get negative 8. Okay, pause the video and now complete the rest of the y column for yourself. Your y column should look like mine. So it should be negative 15, negative 8, negative 3, 0, 1, 0, negative 3, negative 8, and negative 15. We're now going to find the first differences, and if you recall, that means we subtract one column from the next. And so I get negative 15 subtract 8. That gives me negative 7. Negative 3 subtract negative 8 gives me negative 5. Negative 3 subtract 0 gives me negative 3. 0 subtract 1 gives me negative 1. 1 subtract 0 gives me 1. 0 subtract negative 3 gives me positive 3. Negative 3 subtract negative 8 gives me positive 5. Negative 8 subtract negative 15 gives me positive 7. So now I've got the first differences. I can now calculate the second differences. And I'm going to do the first two, and then we know the pattern. So negative 7 subtract negative 5 gives us positive 2. So we do negative 7 subtract, it should be actually negative 2 in this case. Okay, so that gives us negative 2. And then negative 5 subtract negative 3 gives us negative 2. And we know the pattern is the same. The second differences are all the same, so we can just write them like this. With the table of values, we can now graph the parabola, graph the quadratic equation, and reveal the shape, the parabola shape. Just going to remind you that these here, the x and y values, are your coordinates. And so we have -4 and -15, -3 and -8, -2 and -3, and I'm sure you understand that pattern. Those are your coordinates, and you're going to then graph those coordinates onto the graph and create a parabola. And so the first one is -4, -15, and so I'm just going to place that here, -4 and -15. And the next one is -3 and -8. And the next one is -2 and -3. All right, and I'm going to stop there. I want you to pause the video and complete the quadratic equation, or sorry, plotting the quadratic equation for yourself and revealing the parabola. And then you can check your answer. So just pause. So your parabola should look like mine does right here. And I used these coordinates in case that's unclear. We are now going to discuss the characteristics of this parabola. And so first let's talk about its vertex. If you recall, the vertex is the peak of the curve, either the low, the minimum, or the high, the maximum point of the curve. So in this case, it is the point 0, 1. It's right here, 0, 1. Okay, and in this case, it is facing downwards. It's pointing up and facing downwards, and therefore it has a maximum. And now we can talk about its y-intercept. In this case, its y-intercept is going to be the same as its vertex because that's where it's intersecting the y-axis. So it's 0, 1. And what are the zeros? And the zeros are the same as they were for the previous quadratic equation that we graphed, because this is basically just the same quadratic equation flipped. And so the zeros are -1 and 0, and 0 and 1 and 0. And then our step pattern is also going to be the same. Here it's change of 1, here it's a change of 3, here it's a change of 5. And so our step pattern is 1, 3, 5. What do we notice about the second difference is all the same. Okay, so just a couple final points to finish up this video. I wanted to point your attention to the fact that the equation for a parabola is actually written as this: y equals ax squared plus bx plus c. Now our equations don't quite look like that, and that's because in our equation b was equal to 0. What would happen if b was equal to 0 in this equation, where we could substitute in for b 0, and if we multiply it by x, what do we get? We get 0, so we don't need to write it anymore. And then we get ax squared plus c. But you might be asking yourself, but sir, where is the a? And you can kind of looks like ours, but where is the a in our equation? Well, the a in our equation, the a in this equation here is equal to 1. And so there's a little 1 here, 1x. We've talked about that many times. And here it is equal to, a is equal to -1. Okay, and that allows us then to take note of something, a characteristic of the parabola that we can determine just based on the equation. And that is, if a is greater than 0, as in 1 in our case here, then the parabola is going to open upwards. It will point downwards and open upwards. Now, if a is less than 0, as in this case here where it is -1, then it will point upwards and open downwards. Okay, and so that's a very important characteristic of the parabola that we can know just by looking at the equation. And then one final point here is, if we have the equation in the form ax squared plus c, this c is always going to be our y-intercept. Right? And that's because if I substitute in, if you think about it, if I substitute in for a sorry, for x 0, and so I get 0 squared plus c, I end up just getting 0 over here, so I end up getting y is equal to c. And that tells me the y-intercept is the value of c. And you can see it in our examples here where the y-intercept was -1 and where the y-intercept was +1. Alright, so that concludes this video. You should be able to complete the first 2 handouts I did with you just now in the video, as well as 2 other handouts which are slightly more complicated but the same basic principle, and then you'll be good for this section. Good luck.